Similar right triangles. Similar right triangles are right triangles that have the same shape, but not always the same size. Their angles are congruent, their sides are proportional. And this is a good example. We have 52, 52, 90, and 38. Our angles are all congruent. The sides have a proportional situation. So we have 7 to 14, that would be multiplying by 2. 9 to 18 multiplying by 2. And 11.4 times 2 would give me the 22.8. All you need to know for this little part is if you have right triangles and you know one of the acute angles are congruent, you can say you have similar triangles. Here, what you need to know is that if you draw an altitude, so what is an altitude, you may ask? An altitude is if you go from, oh, that's perfect actually. If you go from the 90 degrees to the hypotenuse, you draw this line, you get an altitude. It should make 90 degrees on either side. What it does is it's going to take my triangle, so this big one, and make 3 similar triangles. So you have the big one. You're going to have this side will be similar to the big one. And you're going to have this side being similar to the big one. Because of all this similarity, we can solve. What you're going to do here, we want to solve for BC. Okay? So we're going to start with our little triangle. So we know BC is my x. In this situation, it's across from that right angle. I'm going to label the hypotenuse. The other side I know is DC. I know that's 3. Okay? The next thing I want to do is look at my other 2 triangles. I have sort of this left side one, and then I have the whole thing. The one on the left doesn't deal with my x at all, so I kind of want to ignore that and instead want to deal with my whole big triangle. Well, once again, I know, come on, pencil, there we go. This time I know BC is still x. But if I look at this, my 90 degrees is now up here. This is no longer my hypotenuse. Okay? The hypotenuse is this side, which is 4 plus 3, which is 7. So that means AC. So AC is equal to 7. This is my hypotenuse. When I go to set this up, I'll start with this side. I just want to basically make a fraction here. X over 3. Just know your x is your hypotenuse here. When I do this other side, I still want my hypotenuse to be up top. So in this situation, AC will be on top, which is 7. And x is on the bottom this time. Now what we're going to do is cross multiplication. Cross multiply. 3 times 7 is 21. X times x is x squared. This now is a final step. We just need to do our square root, which again, you can use Google or your phone. Should get about 4.58. This is just them working out the problem. I just did it up there. This here, they're talking about a problem that was in the study. I just went ahead and recreated it down here for us to solve. This is another way you may see similar triangles. And what I like to do in a situation like this like 6 compared to this 15. The 6 is the shorter side, so I like to put an S by it. And this 15 is kind of the middle side, and then this blank is my longest side. Then I go to my other triangle, I do the same thing. My longest side, my short side, my middle. We can see these longer sides just aren't used here, so I can cross them out if I want to. And then I might set up a ratio of small over middle. You could do middle over small, but that's just what I'm going to do. So I get 6 over 15 minus x equal to 3 over x. And now I have a cross multiplication problem again. If it will write for me, I will do it. Where do we go? Oh, we gotta go down. So we got 6 times x, which is 6x. Be careful here. We have 3 times 15 minus x. So 6x will equal 3 times 15 minus x. We got to do distribution in this situation. So 6x will equal 45 minus 3x. Now we want to solve for x, so we're going to go ahead and bring our 3 over to our 6. That will give us 9x equal to 45. And finally divide both sides by 9. X equals 5. So really all you're doing here is setting up fractions and solving. We'll practice this more. Hope you have a good day.